Hello. Hello, everyone. Okay. Can everyone hear me? Okay. Yes, I'm guessing that's a yes. So, hope you enjoyed submitting the third assignment. How did you find the third assignment on a scale of 1 to 10, 10 being incredibly difficult? So how would you characterize? Just any feedback about the third assignment? Maths 3, physics 7, 8. Okay. Okay. Right. Yes, I needed to be more specific. Okay, let's say maths. What about maths? Maths 3. Specifically maths. Give me some numbers. 3, 4. Okay, 3, 4, 3, 4, 4. Okay. All right, just generally. Okay, so I wouldn't say that physics was like more difficult. It's just I think you are less used to physics where you actually need to solve problems. Okay, so today we're doing maths and we continue calculus. So calculus, basically it's differentiation and integration. And last time when we did differentiation, I said differentiation is super easy. And it is, because differentiation is free rule, which you should already know by now, is the product rule, the quotient rule, and the chain rule. If you know these three rules, you know differentiation. There's nothing more, nothing less. Okay, you can do if a function is differentiable, you can find its derivative by applying these three rules. The opposite of differentiation is integration. And integration is a completely different story. You well, integration is an art. It's really a form of art. You can study integration for 5 years, 6 years, and you still will be far from perfect. You won't know all integration. Yes, sure, there are plenty functions that are not differentiable. Like I'll show you an interesting function which is not differentiable. So yeah. So what am I talking about? Oh yes, integration. Sorry. And there are like if you look at like any calculus book, differentiation would be like 5 pages, and integration could be 3 or 4 different books on differentiation. Like honestly, you can't get perfect at integration. Okay, integration is incredibly interesting. It can be incredibly difficult, and it's very, very useful. There are some functions that are not differentiable. There are many more functions that are not integratable. So some functions are just simply not integratable. And I'll give you an example of that as well. So what function is not differentiable? So I'll share my screen. Okay, you should see my screen. So, for instance, function fx, non-differentiable. Where's the chat? Okay, non-differentiable. So a function which takes a simple function, I think. I forgot. It's the Dirichlet function. It's the Dirichlet function. It takes the value 1 if x is a rational number. If x is rational. And it takes the value 0 if x is irrational. So we can plot some points. So I don't know, 1. 1 is a rational number. So f of 1 is 1. F of 1 is 1. Square root of 2, which is about 1.4, is irrational. So square root of 2 is here. So point. So f of 1 is 1. F of square root of 2 is 0. F of pi is 0. So this is square root of 2, 2, 3. So this is pi. F of, I don't know, 2 is 1. So it's a function contained, and because rational and irrational numbers can be very, very close to each other, basically you end up jumping from back and forth. So you end up with lots and lots of points here, and lots of points here. And if you try to find the derivative, it's impossible. You can't find the derivative of this function. Because at any point, in an infinitely small distance, it jumps to infinity. Okay. So, or we can say something simpler. So for example, y equals, it's Dirichlet is a French Dirichlet function. Dirichlet function. Yeah, there are many different Dirichlet functions, but this is one of them. Dirichlet. It's not Dirichlet because it's French. And they don't pronounce the T at the end. Another simple example would be y equals sine 1 over x. Y equals sine over x. So let's draw that. Y equals sine 1. Nope. It's not what I wanted. Yeah. So you can see that it goes like this and then starts wiggling. So as it approaches 0, it's not differentiable at so the Dirichlet function is not differentiable at any point. non-differentiable at any point. Any point, because the slope is not undefined at any given point. And y equals sine 1 over x, which looks like this. Is not non-differentiable. Non-differentiable at x equals 0. Also, the one and only y equals modulus x. I love this function, and it's non-differentiable at x equals 0 because there's no derivative at this point. Because you can't draw a tangent. You can't draw a tangent at this point. Therefore, no non-differentiable. At x equals 0. You need to remember that when we say derivative, we actually mean a derivative at a point. There's no like derivative in general. Derivative is derivative at a point. And when you say derivative function, it's just the derivative of many different points. I don't want to go too deep into that. Non-integratable functions, and I love those because you might have heard. Okay, question. Have you heard that to find the area under a curve, you need to find the integral? Or yes or no in the chat, please. Okay. All right, so only yeses. That's very good. That's impressive, guys. So to find the area under a curve, you need to find the integral. That's in short. And in reality, what happens is if you have a curve, let's say this f of x, and the area under this curve, area between a and b. So area is the integral of f of x dx between a and b, of course, because otherwise, what area look? You need boundaries. But then the thing is that you can have a function, a perfectly valid function. So for example, this one, or e to the power minus x squared. Here it is. This is a function, but you can find, and you can certainly find the area, because I mean you can non-integratable. Y equals y integratable. So f of x is equal to e minus x squared. This is a non-integratable function. Even though you have a graph, you have an area under the graph, and yet it is impossible to find there's no integral. There's no function whose derivative is that. Okay? Non-integratable. However, the very close function, like this, x e minus x squared, is integratable, funnily enough. This one can be integrated. But this seemingly simple function, no, cannot. even though the area is very clearly defined. And this is the bell curve. This is the normal distribution curve. It is. Oh, yes, Ahmed. How can you prove a function is not integratable? I don't have an answer to this question. Not off the top of my head. That's a very good question. I'll write it down for myself. How to prove. Okay, so so back to integration. Integration is the opposite of differentiation. That means that if you have the integral of a function of f of x dx is a function f of x, which is called the primitive function, such that the integral of a function is a function whose derivative is the original function, such that f strife of x is f of x. F of x is the primitive function, or the antiderivative. Okay. All right. Does this make sense? Does this definition make sense? No, we start at 6 every time. Last week we started at 6:15. That was a one-off. Sorry, does everyone understand this definition? Is there anyone who doesn't? So please let me know. Can you? Yes, it is the first lesson on integration. The first webinar. Is there anyone who does not understand what's written here, guys? Please let me know. All right. Happy to. So when you have, but Aaron, have you done differentiation? How is that possible? You've done assignment 3. That's differentiation. Right. Okay. So you would please rewatch my previous webinars, and you will be able to see this. Rewatch this webinar later. So you need to first study differentiation. Then you'll need to watch this webinar, because the recordings are always published. So let's say if we have a function, so y is equal to sine x. sine x. The derivative of sine x is equal to Ben. Well, it depends. It depends on. It's up to you. It's up to you, Aaron. Can you write integral f of x dx dx? Well, yeah, of course you can. You just do the inner integral first, and then you do the outer integral, and it won't have a problem like this today. If you have a function, the derivative is, let's say y equals sine x. The derivative of sine x is, of course, cosine x. That means the integral of cosine x dx is the variable of integration, is equal to sine x. Well, it's not exactly sine x. It's sine x plus c. And here it is the antiderivative plus c. So why do we need the plus c? Well, because sine x is not the only function whose derivative is cosine x. Okay. So if f strife of x is equal to cos x, find f of x. Now we have we have an option, sine x. The integral, can we say that the displacement is the second integral? I've never heard anyone say that, but I don't see a reason why. Why not? You can't say the second integral. That I don't think I've ever heard anyone use that phrasing, second integral. So f of x equals sine x is a possibility, but so is f of x equals sine x plus 2. Because the derivative of this function, this is one option. This is another option because the derivative of this function is also cosine x. So you can add any number here and it will still be true. That is why we use c. This is the arbitrary constant. So the integral of f of x is the antiderivative plus c. Okay, so let's look at problem 1. We have the derivative of the function, and we need to find f of x. F of x is question mark. Well, you know differentiation quite well, so you can guess that f of x should look like this. It's going to be minus 3 over 2 x squared plus 12x plus some arbitrary constant c. Because this is just by observation, yeah. We look at this and we see that, well, if the derivative is that, we can find the function. Where c can be anything, because if you take the derivative of that, so check minus 3 over 2x squared plus 12x plus c, and that's indeed minus 3x plus 12. So true. But now find f of x if the graph of f of x passes through the point 3, 3, 0. So the thing is that this, if you want to draw this graph, you will see that depending on c, it's a different graph. Well, it's a parabola, so it's for different values of c, it's going to be a different parabola depending on c, and we need the one that goes through the point 30. So what we do is we substitute the coordinates of this point into the equation of the curve. Sub 30 into equation of the curve. All right. So f of x, well, f of 3 is minus 3 over 2, 3 squared plus 12 multiplied by 3 plus c is equal to 0. And minus 3, so that's minus 27 over 2 plus 36 plus c equals 0. C is equal to 27 over 2. I'll cheat a little bit. 36 minus 1 over 2. That's 22.5. So minus 22.5. And that's, and so then you write down your answer. F of x is equal to minus 3 over 2x squared plus 12x minus 22.5. So now we have a function that satisfies both conditions. The derivative of this function is minus 3x plus 12, and the function actually passes through the point 30. We've completed the task. How well did you understand problem number 1 on a scale of 1 to 10, please? So 10 being I understood everything. Okay, lots of 10s. Is it lots of 10s and shy people, or we have lots of 10s in general? Okay, we got 20 people today and roughly 15 10s. Okay, impressive. So the remaining 5 people, I'm guessing 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Remaining 7 people. I hope you understand everything. You're just shy. But please don't. Please let me know if you don't understand something. It is okay. Not to know. Okay. And again, here, what I think I haven't mentioned, that f of x is the integral of that, right? So we have a function. So here we can say that the f of x is going to be the integral of the derivative of x dx, which is the integral of 7x minus 2 dx. Technically, you need brackets here, but brackets are often omitted. So don't be surprised when you see the structure without brackets. It's not a big deal. Just everybody understands this is not integral of 7x minus 2 dx. No, it's the integral of the whole thing. So yeah, and of course we need a few integrals. We need to know a few integrals. The integral of x to the power of n dx is x to the power n plus 1 divided by n plus 1 plus c the integral. So common integrals. The integral, but this only works if n is not equal to -1. If n is equal to -1, then it's x to the power -1, or in other words, it's 1 over x dx. And this is a special integral. It's the logarithm of x plus c. This is the case where n equals -1. So it's a special case. Now then you have the integral of sine x, of course, is cosine x plus c, minus cosine x plus c. The integral of cosine x is sine x plus c. No, there are no special cases for the power rule with differentiation, because it works even if, well, yes, sorry, there is a special case where n equals 0, where you have x to the power 0. The derivative of that is, oh, it still works, doesn't it? Because you take 0, it's 0x to the power 0 minus 1, so it is 0. But x to the power 0 is 1, and the derivative of 1 is 0. So technically, yes, it's depends which way you argue. Yeah, so because you divide by -1, and that's why you have an exception here. The integral of cosine x. Do you need anything else? Is there anything else mentioned in the assignment? We'll add to this list if we need. Okay. So the integral of this. Another very important property of the integral is that the integral is linear. The integral is linear. Integral is linear. That means the integral of f plus g is equal to the integral of f plus integral of g. And also that means the integral of k multiplied by f equals k integral of f. I'm omitting dx. Yeah, dx omitted. Which maybe I shouldn't do, but you'll see this in more detail in the assignment. Basically, what the example, the integral of x plus x squared dx is the integral of x dx plus the integral of x squared dx. Just give me 1 second. All right. You still hear me, see me? Okay. If you have an integral of 7 multiplied by sine x dx, that's 7 multiplied by the integral of sine x dx. And this property is called linearity. It's a very important property of the integral. Like, not not all functions are linear. Well, the integral is not a function, but it's an operator. Not all operators are linear. And now, what do we have here? So here we can simply use the property of the linearity of the integral. So it's going to be 7x squared over 2 minus 2x plus c. All right. So g, the derivative of g is f of x. And we know that f of 1 is 10. So f of 1 is 10. So f of 1 is 7 over 2 times 1 squared minus 2 times 1 plus c equals 10. 7 times 1 over 2, so it's 3.5 minus 2 plus c equals 10. So c is 8.5. So we can find f of x is 7 over 2x squared minus 2x plus 8.5. Now, we know that g stripe of x is f of x. So that is 7 over 2x squared minus 2x plus 8.5. So all we need is to find g. To find g of x is the integral of 7 over 2. Right? So it's like the second integral, plus 8.5 dx. So that's 7x cubed over 6 plus 2x squared over 2 plus 8.5x plus, well, technically you can't use c, so I'm going to use c1. And then we know that g of 1 is 12. G of 1 is 12. So 7/6. So this cancels out, plus 1 plus 8.5 plus c1 is 12. And we can find c1 is equal to 12 minus 8.5 minus 7/6. So 12 minus 8. Minus 2. Where is minus 2? Oh, minus 2. Yes, so this is minus. So this is minus. Does it help? So this is 1 because I'm 1/6. So 12 minus 8.5. That's 3.5. 3.5. 3.5 minus, so 7 over 2 minus a 6th. 321 minus 1, 26, which is 10/3. Please tell me I haven't made. Oh yeah, it is correct. By all means, 10/3. And you got the answer. G of x is 7/6 x cubed minus x squared plus 8.5x plus 10/3. Okay. Good. Now, you can deduce that the integral of we call it the inverse chain rule, although just a second, do we see it again? The inverse chain rule? Not really. Not really. Inverse chain rule. So let's write it down. Inverse rule. If you have an integral of a function f of ax plus b dx, it's 1 over a integral of f of, well, ax plus b. Now, there's a big issue with this rule. Technically, I have to write d ax plus b. It's new variable like this. This is technically correct, but doesn't help. Like memorizing this is not helpful at all. So an example will fit. So if you want an integral of sine 3x plus 2 dx, you know that the integral of sine is cosine. So it's going to be cosine 3x plus 2. Of course, it's minus cosine. But then, because there's a 3 here, it's going to be 1/3 plus c. And that's it. So all you have to do, if you have, instead of x, you have ax plus b. So the rule is, in simple words, if you have ax plus b instead of x, just put 1 over a in front of the antiderivative. Okay. Pretty much it. Sine x squared, that's a different story. Okay, so to do sine x squared, you need to use trigonometric identities. It's a whole other story. And that's the thing. It's not as simple as differentiation. So does not work for sine x squared or anything else, anything other than ax plus b. So sine x squared, for example, if you want to find the integral, I think it's a non-integratable function. I might be wrong, but because it's because sine x is so closely related to e to the power of x. Sine integral of sine x squared. Okay. Yeah, this is one of the really tough ones. Yeah, there is a Wikipedia article of several pages explaining how to do this integral. So no, it's not a simple one. And examples will make you cry. In short, yeah. So question. Sine squared x is doable. Yeah, and it's not that hard actually. And I'll show you how to do this one later on. Okay, so back to this one. Find the antiderivative. So find f of x. So f of x, 2 multiplied by sine 5x, plus x to the power half. It's always better to write x to the power half plus 3/5. So the antiderivative is the integral of that. So the integral of 2 sine 5x plus, and as I said, the integral is linear. So we can do this, dx plus integral of 3/5 dx, which is, so 2/5. As I said, all you need is to put a fifth. It's going to be minus 2/5 cosine 5x. Because of the 5 goes on the bottom, and that's it. Now you don't need a plus c here, because it will have plus c, and plus c. So you can combine them all into one c. How is sine x related to the exponential function? Ooh, that's a good one. So e to the power ix is equal to sine x, sorry, cos x plus I sine x, where I is an imaginary one. Therefore, e to the power ix squared is equal to minus ix squared. It's going to be cos x squared minus I sine x squared. I'm skipping steps a little here. Don't worry if you don't understand fully, but just believe me. Believe when I say that this can be written like this. So if you want to find the integral of this, you'll need to find the integral of that. So if it's impossible to find the integral of that, it's also impossible to find the integral of that. So the integral of sine x squared is just as impossible as the integral of e minus 1 over minus I x squared. Okay, so I hope that makes more sense. Might be a bit far-fetched, but yeah, this is the link anyway. Going back, so this is, we use the power formula, so x to the power half, so it's x to the power 3 over 2 over 3 over 2 plus 3/5 x plus a constant. Okay, so simplify that, minus 2/5 cos 5x plus 2/3 x 3 over 2 plus 3/5 x plus c. And find f of x given that graphs of f of x and f of x intersect at a point which is on the y-axis. What does that mean? So if you have f of x and we have f of x, and they meet on the y-axis, that simply means that f of 0 is equal to f of 0. Okay? That's what it means. So f of 0, and that's f of 0. So all you need to find f big of 0. So minus 2/5 cosine 0 is 1. So minus 2/5 plus 0 plus 0 plus c is equal to f of x, which is 2 multiplied by 0 plus 0 plus 3/5. So c is equal to 3/5 plus 2/5 equals 1. Yeah, you can, Jack, true. You can write sine x is equal to that. That's another link. It's a rearrangement of this formula, in fact. Right? If you take this formula and rearrange it to find sine x, you will get what you got. Well, not exactly, close to that, but yeah. All right, and we got find f of x. So what we need? Oh, we need f of x. So I'm gonna be a bit lazy here. So c, and I've got f of x equal to that, and instead of c, I have 1. Okay. Oh wow, it's been an hour and I've only done 3 questions, but they are enclosed by the curve, by the curves. So I'll speed things up a bit. So this is where you need the areas. So you draw the lines. Y equals x plus 6. X plus 6 is like this, where this point is 6. So this is y equals x plus 6. And y equals x squared. So it looks like this. So you need to find where they intersect. Okay, so we need to find where they intersect. So the y equals x squared. So to do this, you do x squared equals x plus 6. So x squared minus x minus 6 equals 0. So x equals minus 3. So 3 and x is equal to 2. So that's 3 and this is 2. To find this, you need first to find the area under the straight, and what you need is you need to find the area under the straight line, this one, and then subtract the area under the curve. Oh, -2, of course. Yeah. Sorry. In a bit of a hurry, of course. So area 1, so A1, and the pink one is going to be area 2. So the area that we want is the area between the two curves. So it's this bit. So area is equal to area 1 minus area 2. So area 1 is the integral between limits -2 and 3 of x plus 6 dx. And area 2 is the integral between limits -2 and 3 of x squared dx. Now you can do them separately, or you can use the property of the integral of linearity. It works both ways, because if you have the same integral of x plus 6 dx minus the integral of x squared dx, it's the integral of x plus 6 minus x squared dx between limits -2 and 3. And then you have x squared over 2 plus 6x minus x cubed over 3 between limits. Now here you don't need a constant because this is a this is a definite integral. So you substitute 3, there's going to be 9 over 2 plus 18 minus 27 over 3. Right, go bracket minus another square bracket minus 2. So that's 4 over 2 minus 12 plus 8/3. Okay. We get 9 over 2 minus 9 over 2 is 4.5 minus 2. That's 2.5. 18 minus 12 plus 6. Oh, that's plus. So that's 40 plus 40. 30. Okay. You know, I had a fever for a few days. I did not expect that a 38.5 fever brings your brain activity to to 0. Minus 27/3 minus 8/3, which is 35. So minus 35/3. So 32.5. I don't like this. 32.5. So that's 65 over 2. 65 over 2 minus 35 over 3. 65, 195 minus 70 over 6. 125 over 6, something like that. That's the area separated by the curves. So you just find the integral and then you put in the limits and nothing else, nothing more than that. And problem 5, this is a derivative of the integral. Now, fundamentally, we know that if we have the derivative dx of the integral of a function dx, that's always because the derivative is the opposite of integration. And that would be just f of x. But there's a catch. You see here, we have dx, and here we have dx. But here we have dt, and here we have dx. So we can't use this rule. It's the you can't use the main theorem of calculus, it's called. So we can't use that. So we find the integral separately. So we find 0 to 3t x squared plus t squared dx. Now, when we do this, we have to treat t as a constant, because the integration is with respect to dx, not with respect to x. Sorry, yes, not with respect to t. So it's the integral. So it's going to be x cubed over 3. That's the normal stuff that we do. Plus, now t squared is just a constant. It's just like a number 8. So it's t squared x between limits 0 and 3t. Do you understand what I've done here, guys? Yes or no? Do you understand how I got this expression? I've treated t squared as a constant. So 7 yeses, 8 yeses, 9 out of 19. Okay. Now I substitute instead of x. So it's going to be 3t cubed over 3 plus t squared multiplied by 3t. And then substitute 0, but that's pointless because minus 0 still is going to be 0. And all I need is just 27t over 3, so 9t squared plus 3t cubed, and that's the answer. Oh no, that's not the answer yet. That's the integral. And now we find the derivative of that, d over dt. T cubed. Oh, okay, interesting. So that's 12t cubed. All right. 12t cubed, thank you. 27t cubed over 3. Yes. So that is of 12t cubed. So we find the derivative. So it's 36t squared. And that's the answer. 36t squared. All right. Now, there's one rule of integration that is very similar to the product rule. And that's called the integration by parts. Integration by parts. By parts. So how do we achieve this? Well, we have the product rule. UV is equal to U strife V plus UV strife. Now, if we integrate all sides, okay, so because with the integral of UV strife is just UV, is equal to the integral of U strife V dx plus the integral of u v strife dx. And if we rewrite this, the integral of u, it doesn't really matter how you do it, u v strife dx is equal to uv minus integral of u strife v dx. This is the integration by parts formula. Okay. We have this dx, of course, dx and dx. Yeah, so I haven't changed anything here. I just used the fact. I used the main theorem of calculus to show that the integral of the derivative is just what's inside. And how do you use here? Well, you need to decide which one is u. You need to, and which one is v. So there are ways how to choose. There are ways how to choose which one is u, which one is v. In this case, u is going to be x, and v, well, we don't know v yet, but we know that v strife, v prime, is cosine x. U prime. So if u is x, u prime is 1. And if v strife is cosine x, so this is u, and this is v strife, then v is sine x. So this is going to be x multiplied by sine x, so u and v, minus the integral of u strife v, so 1 multiplied by sine x dx. And we know this integral, so it's going to be x sine x minus cos x plus c. It's going to be plus cos x plus c. Okay. So sorry, I'm rushing a bit here, but here you need to do the same thing. You say u is x squared, u prime is 2x, v prime is sine x, so v is minus cos x. So you do this, and you have x minus x squared cos x minus the integral of u strife v, so 2x multiplied by minus cos x dx. And then you do this by parts again. By parts again. So I will leave it here. Do it, finish by yourself. Finish. And going on further, by using trig identities, by using substitution. Okay, so let's start with A. So we have the integral from 0 to pi over 2 sine x cos x dx. So using trig identities, sine x cos x, well, we know that 2 sine x cos x is sine 2x from assignment 2. Therefore, sine x cos x is a half sine 2x. So it's going to be the integral. It's going to be half the integral of sine 2x dx between limits 0 and pi over 2. So it's going to be a half times a half, so a quarter of cos 2x between limits of 0 and pi over 2. You substitute pi over 2, so cosine of 2 times pi over 2, so cosine pi, so it's a quarter cos pi minus a quarter cos 0. So cos pi is -1, so it's minus a quarter. And cos 0 is 1, so minus a quarter, so minus a half. The integral of that is true. It is the integral of sine x is minus. Yes, thank you. Sorry about that. Plus, so plus half. And now let's do it by substitution. So substitution is something we haven't done yet. Maybe you have. I really hope you have. Who's done substitution? Give me a yes or no. Integration by substitution. It's a very powerful instrument. Integration by substitution. Okay. So you have the integral of sine x cos x dx is from 0 to pi over 2. So substitution. So you choose what you're going to substitute. And here, I believe it really doesn't matter. I'm going to go with sine x. U is sine x. Okay. Now du is sine x. Now if you have du over dx, that's the derivative of u. It's going to be cos x. And what I do now is I say, oh, from here, I make du the subject. So dx the subject, sorry. So dx is going to be du divided by cos x. So what happens now? I have the integral. Instead of sine x, it's u. Instead of cos x, well, instead of dx, I have du over cos x, and here I have cos x. Cos x cancels, and I'm left with the integral of u du. Okay, which is absolutely beautiful. Du, which is u squared over 2. Notice that I'm not doing anything with the limits yet, but I can. I need to change the limits as well, u1 and u2. And we can find them u1 and u2 by substituting x1 and x2. So u1 is going to be, you substitute 0, so sine 0, and u2 is going to be sine pi over 2. So it's going to be 0 and 1. So it's u squared over 2 between limits 0 and 1, which is a half. Exactly what we had before. Okay. So integration by substitution is a very powerful tool. Integration by parts is a very powerful tool. You need to know these definitely for A level, you need to know these. But the difficulty of these varies greatly, absolutely. And yeah. Okay, finally, Find the volume of the concatenated cone by slicing into multiple thin cylinders. This is where we can use Riemann sums. Okay. So what happens here? We have a cylinder. We want to slice it. We can slice it into horizontal slabs. Like this. The thickness of one slab, let's call it delta x. Delta x. The volume of this slab, the volume is going to be, well, we can assume because the slab is very thin, we can assume that it has the same radius everywhere. So instead of a truncated cone, this is like a cylinder. This is approximately a cylinder. Approximately a cylinder. Cylinder of radius r. Cylinder of radius r. So the volume is going to be pi r squared multiplied by delta x. And that's important to understand that the volume of this slab, of this bit, is pi r squared delta x. To find the volume of the whole thing, we need the sum of all of these little volumes. Sum of pi r squared delta x. The only thing is, well, we also need to express. We need to express the radius in terms of x. So this is the x-axis. Let's start with 0 and ends with 3. Let's draw the graph. Let's draw the graph separately. So this is the x-axis, and this is the radius. So the radius depends on x. So when x is 0, the radius is 4 meters. 4 meters. And when x is 3, the radius is 1 meter. 1 meter. So radius depends on x. Yeah, the further up the cylinder you go, the smaller the radius. What's the function? R of x. What is this function? Can somebody help me? Alfie, good attempt, but no. First of all, the gradient is going to be negative. Minus x plus 4, Alistair. Yes, thank you. It's going to be, well, 4 minus x. 4 minus x. The radius is 4 minus x. So you can substitute that here. The sum of pi 4 minus x squared delta x. Now, what we do now, we do a trick. we do the limit of this. We find the limit of this as delta x tends to 0. What does that mean? That means that the slices that we cut, the thickness of the slice becomes infinitely thin. So rather than taking cylindrical slabs of some sort of thickness, we take cylindrical slabs of which are infinitely thin. Delta x 0. And if you look at this structure, this looks awfully familiar. If you replace the sum symbol with the integral, then you rewrite the function pi 4 minus x squared. And delta x, when delta x tends to 0, it becomes dx, because the difference between delta x and dx is the size of that thing. When delta x becomes infinitely small, it becomes dx. So look, do you see the resemblance? Do you see how this is the same as that? It's just the limiting value of this sum. And you can take this integral. You expand the bracket, so you take pi out, integral of 16 minus 8x plus x squared dx. So it's pi, oh, of course, the limits between 0 and 3, 0 and 3, 0 and 3. So you get 16x plus minus 8x squared over 2 plus x cubed over 3, 0, 3. Pi 48 minus 4x, 4 times 9, 36, plus 27 over 3, 9, which is 48 minus 36, that's 12, 12 plus 9, 21 pi, and that's the answer. Okay. Right. Now, you have, so for this assignment, you have over a month. You have, what, 5 weeks? Well, just under 5 weeks to do this assignment. I'd really recommend you, if you haven't done integration, like study it, because it's a big deal. Yeah, integration is a huge deal. It's used a lot in physics, and yeah. I think I knew a family. I think I knew a family. And they had kids, and if the kids started dating, so for example, the son or the daughter started dating someone else, they would always ask, oh, so what do they like doing? Can they integrate? That was a big thing. Like, there was like the second question. What is that? What is the other person like, and can they integrate? And if they can integrate, that's a good that's a good choice. I don't know. It's it was quite funny, but I mean, knowing how to integrate gets you places. definitely, I would say. Certainly that shows in the salaries of the people who are very good at integration. They work in they have really high paid jobs. This is used in finance, banking, risk assessment, software engineering, like everywhere. So yes, welcome to the wonderful world of integration. So they are coming. The assignments that are designed to help you, they are coming. It won't be published. I'm hoping it can be published before in the next week or so. So it will be like assignment 5, but it will be due end of January. So you have a chance to do that over the Christmas time. So you can work on 2 assignments. So that's why we're giving you plenty of time for this one, and even more time for the other one. Hope that makes sense. They're being prepared now, and we'll publish them before Christmas, or at least we'll do one subject. Was the current physics assignment is going to be on center of mass. So we'll be looking at the center of mass of different shapes, and we will be using integration to do that. Early Christmas present. Yes, they won't be easier because they will be A-level stuff, purely A-level stuff. But they might be on topics you haven't studied. For the mock, so you can skip those. I mean, by all means, it would be great if you can go ahead a little bit and study the topics, but don't stress yourself too much. Okay. I understand that you'll need yes, those for year 12s. We'll have for year 12s and year 13 separately. Oh, sorry. And yes, we are coming to mocks, and please, if you need to focus on your mocks, please do. Like, talk to your tutor and ask for an extension if you need. We'll be accommodating in this during this exam season. Some say it's holiday season, but in many schools it's exam season. All right, enjoy the rest of your evening. Hope that was useful, and see you next week.